Hello, my Math 3 scholars. Today we're going to learn about how to come up with an equation for a line when we're only given points. And we're going to completely use Desmos to come up with this. So an algebraic equation can be found for any data that consists of you have to have at least two variables. So you've got to have an x and a y. Okay, so you got to have 2 points or two variables that you're looking at. Okay, and you need at least 2 points in order to do that. Now, notice I said find a line of best fit using the Desmos calculator for each set of data. So we're going to first start with this example here, A. Now, in order to do this, you need to go to Desmos, and the first thing you have to do is key in those data that you're given. So we're going to go up here to this big plus sign that says add item, and you're going to add a table. All right, and I'm going to put this table in. 0, 5, 10, 15, 20. And this is coming straight from the paper that's on your CAMI document or the one I just showed you in this video. Okay, then I'm going to put the rest of the information in. 10.1, 2.8, 8.1, 16, and 17.8. Okay, once you have that information in, you're going to come down here, and what we're going to do is we want to see if first a straight line would work. So you're going to do a Y, and you're using your keypad for this, Y, and then hit the number 1, and it automatically makes it like a subscript, and that's what you want. Then you're going to hit Shift and the key that's beside the number 1 to give you that little curly thing. Okay, so Y1 and the curly thing, and then we're going to do mx1 plus b, because that is the equation for a linear equation. Now you can see here that I do not go through my green dots for this line. Okay, so it's not a linear equation. So now I'm going to go back and I'm going to change this. Let's try if it's quadratic. So you're going to do ax1, and this time you're going to do Shift 6 to do a squared there, plus bx1 plus c. Okay, this is for a quadratic function, but you can see I'm not going through my green dots that I need to go through. Okay, so it's not quadratic that's going to help us. All right, so now let's go and change this squared here to a 3. And then this is going to be squared. And then that means we're going to have a cx1 and a plus d. Okay, so for a cubic function, you can see that we're going through all those green points that we have plotted. So we've just come up with our equation, and it's all of these A, B, C, and D, and I can't highlight them, it won't let me. But these A, B, C, D that you see right down here where I'm putting this red circle, these are your numbers that are going to go in the places of A, B, C, and D in your equation. So it's going to be y equals negative 0.012, we're going to round 3 decimal places, x cubed, plus 0.433x squared minus 3.297x plus 10.081. And so this is what it'll look like on your paper as your equation of the line of best fit. Okay, and I'll leave that there for just a second. Now, if we wanted to do the polynomial function that has a graph that passes through these 4 points, okay, so I'm going to go back to Desmos, and this time I'm keying in these 4 points here. So let's go to Desmos, and I'm going to take out what I had done, and I'm going to delete these. And actually, it probably is easier just to hit X and then do an add table again, okay? That's your easiest way to do it. Okay, we're going to do 0, negative 3, 1, negative 1. And I'm taking these straight from the paper. 2, 5, and negative 1, negative 7. Okay, those came from right here on your paper. These points right here. Okay, I just keyed those in. All right, so there's our points. Now that does not look like a straight line, but let's see. Y1, and then Shift and the key that's beside the number 1, mx1 plus b. Okay, Now you can see that that doesn't quite go through this point right here, okay? You can see it's a little bit to the right. So it's not a linear. All right, let's try ax1 squared plus bx1 plus c. Okay, again, you can see that this blue point here is just a little bit to the left. It's not going straight through that blue point, okay? So let's hope that a cube function is going to work. So we got ax1 cubed, oops, ax1, there we go, cubed, plus bx1 squared, plus cx1 plus d. All right, now this time it looks like we go through all of the points directly through the center. So this is a cubic function. And again, right here are your a, b, c, and d's. So we're going to write y equals 1x cubed, so I don't have to put the 1, minus 1x squared, again, I don't have to put that 1, plus 2x minus 3. And that's what it's going to look like. Okay, as always, if you have questions, let me know.